Welcome back, everyone, to our ARSET training series, Methane Observations for Large Emission Event Detection and Monitoring. Today is part 2 of our training series, EMIT Data Products and Visualization. My name is Melanie Follett-Cook. I'm a researcher at NASA Goddard Space Flight Center outside Washington, D.C., and project scientist of ARSET. In part 2 today, we'll show how to access and visualize methane plume information from 3 different platforms. A reminder that there will be one homework assignment after this training. It'll be available today after part 2 is complete and due 2 weeks later on December 5th. A certificate of completion will be awarded to those who attend all live sessions and complete the homework assignment before the given due date. Now we'll begin part 2 of this training, EMIT Data Products and Visualization. By now, you might know me, Melanie Follett-Cook, on the right. Today, I'm glad to be joined again by Dr. Andrew Thorpe, a research technologist with the Jet Propulsion Laboratory, as well as Dr. Philip Broderick, a data scientist also with the Jet Propulsion Laboratory. By the end of part 2 today, we hope that you'll be able to navigate EMIT observations through the U.S. Greenhouse Gas Center portal and use the EMIT Visions data portal to explore ancillary data that can contextualize methane enhancement observations. As a reminder, if you have questions during today's training, you can put them in the question box within WebEx at any time. At the end of the training, we'll try to address as many questions as we can, and we'll post the questions and written answers to the training page within about a week after the training. A quick review of part 1 before we get started. Methane is a potent greenhouse gas, and scientists have observed its growth in the atmosphere over recent decades and accelerated growth in recent years. We learned that the U.S. Greenhouse Gas Center, led by NASA, EPA, NIST, and NOAA, is part of a national strategy to advance and integrate U.S. greenhouse gas measurement, monitoring, and information system. The goals of the U.S. Greenhouse Gas Center involve making data that supports decision-making, improve the quality and reliability information, and ultimately provide users with consensus information to enable climate change mitigation. We learned about satellite observations of methane and how point source imagers, like the EMIT sensor, can detect methane point sources, which are emissions of methane from a distinct location on the ground, and that these emissions can come from different emission sectors, such as oil and gas, landfills, and agricultural activities. We learned how EMIT methane observations can be used to locate methane sources associated with known pieces of infrastructure, which can lead to mitigation activities, discover unexpected emissions, maybe not in inventories, such as pipeline leaks or new sources, and track methane point source emissions over time. We also learned about available data products from EMIT, such as methane enhancement maps that show enhancements of methane above the background of their scene. And with that, I'm happy to turn it over to Dr. Andrew Thorpe, who will start part 2 of today's training. Take it away, Andrew.
Thanks, Melanie. I'm going to transition to the next section here on accessing large emission event data from EMIT. There are 2 main questions about large emission events. The first one is there methane detected at this location? And we can answer this question by looking at methane plume imagery like I'm showing there on the left. But there's a broader question. How much methane has been emitted from this location over time? And that requires multiple observations where you can track the emissions over time. And these questions both require different amounts of information to answer these types of questions. Addressing these questions allows for different action. For our first question, is there methane detected at this location? There are 3 example actions that we've identified here. Operators can send technicians out into the field to check for leaks or damage. State agencies can send out employees to locations to assess emission rates or compliance issues. And landfill operators, as an example, can identify opportunities for methane capture. And these are just 3 examples to give you a sense of actions that can come out of these types of measurements. For the second question on how much methane has been emitted at this location, this can answer different kinds of questions and lead to different actions. So inventories can capture short-term but large-scale emission events. We can quantify compliance violation scope when standards are defined by the scale of the emission. And we can assess how jurisdictions, both domestic and international, are performing relative to their stated obligations. So where are we currently? We are able to identify methane emissions for a specific location, and we can attribute them to different emission sectors. We are currently working to understand how much methane is emitted from specific locations, and that is dependent on emission estimation, which is something that we're working on, and then characterizing emission variability over time, also something that our team is working towards. So in the remainder of this training, we're going to be exploring different ways to look at the EMIT data, and I'm going to be focusing first on the U.S. Greenhouse Gas Center web portal. So this is the interface that you'll see when you go to the U.S. Greenhouse Gas Center, and I thought I would just provide a high-level overview of its current capabilities. This is an effort in partnership with NASA, the Environmental Protection Agency, the National Institute of Standards and Technology, as well as NOAA, and provides information at different scales, spatially and temporally. There's a navigation bar in the upper left. We'll start with the Stories button. The U.S. Greenhouse Gas Center features a number of stories that span different aspects of greenhouse gas monitoring from different state agencies. And there's a whole host of these stories that I'd encourage folks to take a look at. I will just highlight a few that are relevant to this training. A story on tracking methane plumes from the space and sky that feature both airborne observations with ARSET and EMIT observations, as well as the discovering large methane emission events with remote measurements section that gives you an overview of the EMIT instrument and our measurement capabilities and the data sets themselves. We can next go to various topics. The latest topic from the U.S. Greenhouse Gas Center is an exciting one, and this is featuring urban emissions. Again, you can go ahead and check this out on your own time, but there are a number of stories and resources for the urban emissions, and this is something that's going to continue to grow over time. And there are 3 core science focus areas that are shown here. We've got gridded anthropogenic greenhouse gas emissions at a global scale. Also on a global scale are natural greenhouse gas sources and sinks. And the most relevant to this training, the new observations for tracking large emission events. And we'll click on that, and you can go to this site that gives a nice overview of the EMIT methane observations and some of the history, examples of why we care about methane emissions, why methane is an important greenhouse gas. We've got some nice examples of making methane a invisible gas visible, right? Using these imaging spectrometers where you can actually see where the methane plume is relative to infrastructure on the ground. This is an example in the Permian Basin. We've got examples from landfills as well, where you can clearly see the origin of a methane plume at this landfill as well. Also highlighting examples in airborne program of things like natural gas pipeline leaks. This is an example that was shared with an operator and it led to direct mitigation, so actionable result. And prospects for the future of these types of capabilities. So next, we're going to explore some of the data sets in more detail by going up to the top of our page and clicking on Data Toolkits. What's exciting about the U.S. Greenhouse Gas Center is we're building additional capabilities to visualize and interact with the data. We've got a nice data catalog that's very complete, an interactive map that can start to pull different data sets together, as well as a Jupyter Hub for open source code that folks can use and expand and improve upon. We have a few featured data tools that are shown here. On the right, the NIST Tower Data Viewer, a NOAA Concentration Viewer, and most relevant to this training, the EMIT Methane Plume Viewer. I'm going to go ahead and click on that. And this takes us to our EMIT Methane Point Source Plume Complexes sort of information sheet that talks about the EMIT measurements and provides an interactive map that you can open as its own browser tab. So I'm going to go ahead and do that. And what this does is it defaults to the United States, and it shows all of the methane plumes that were observed with EMIT to date. We're going to zoom into the Permian Basin in the Texas area, and you can start to see those locations of those methane plumes in various parts of the Permian Basin. We're also going to be zooming in specifically to a methane plume of interest, and here is a nice example. You can see the outline of the methane plume here, and you can see a nice base map image below it. If you click on the polygon there, you can see the methane plume specifically called out. You can zoom in into more detailed view. You can, using this eye in the upper right, you can turn off and on the plume, and you can start to see where the plume is the origin. So if we were to zoom all the way in here, you could see that it appears to be associated with this gas compressor station pretty clearly. There's a lot of additional information that I wanted to point out here in the lower left. We've got ancillary information about the maximum plume enhancement value and an uncertainty that's associated with it. There is a link to the ORNL DAC to download the GeoTIFF image that is for this plume. There's information about the lat longs, the orbit information as well, and some other information. So you can sort of interrogate that in more detail. If we were then to zoom out and scroll across the area, let's look at another example. Here's another example of a methane plume. Click on the methane plume there, and again, it's pretty clear that the emission source is coming from a facility there, and that's another likely a compressor station. So those are just two examples of methane plumes in the Permian Basin that you can look at through the U.S. Greenhouse Gas Center. Let's go ahead and zoom out of the Permian Basin and look at a few other examples in the United States. We're going to head up to this example, which I think is a fascinating example of a methane plume. It appears to be coming from that looks like these are waste lagoons. So this is basically wastewater that is associated with what appears to be, if you do a little bit of digging, a sugar mill that's using beets to create sugar. And it appears that there's a lot of methane coming off of this waste lagoon. And this is a sort of an exciting example because it is an example that is not from oil and gas, the oil and gas sector. It is from a different emission sector. We know that we've seen emissions from waste lagoons from different sectors, like from the agricultural sector, from dairies in California, as an example. This is a distinct example of methane coming from a different type of a waste lagoon. All right, we're going to zoom out from this example, and we're going to head close to home for me, and that's the LA Basin in Southern California, where JPL is located and where I live. There are a few examples of methane plumes in this domain that are of note. If we focus just north of Anaheim, we can see the outline of a methane plume here. This is the Olinda Alpha landfill, and if you look at this methane enhancement, you can see that it is associated with this specific facility. There's another landfill called the Chiquita Canyon landfill near Santa Clarita, and you can see that landfill extent and the associated methane plume from that landfill as well. And we're going to then continue into the San Joaquin Valley and increment our way up to an example that I showcased in the first ARSET training. And this is that example of that sort of regional enhancement associated with agricultural emissions in the San Joaquin Valley. So these are examples of methane plumes in the United States, but obviously we've got coverage beyond the United States. And I wanted to just showcase a few other areas that we highlighted in our first ARSET training. We talked about the Permian Basin being an area where we saw a higher density of methane plumes, and that corresponded with our bottom-up emissions inventory, where we would expected to see methane emissions from those inventories. As you might recall, Turkmenistan was another area where we would expect to see methane point source emissions. And as you can see from the distribution of these blue locations of methane emissions, there are high densities of these methane emissions, along the coast, the western coast of Turkmenistan, and in other pockets along the southern border of Turkmenistan, as an example. And then finally, we talked about China coal being a significant methane emission location, and you can start to see higher densities of methane emissions in this region of China that are associated with, coal mine activities and coal mine ventilation shafts that are emitting methane. So this has provided a high-level overview of the EMIT methane plumes observed using the U.S. Greenhouse Gas Center web portal. And now I'm going to hand it off to my colleague, Phil Broderick, who's going to do a deeper dive into some of the EMIT methane results using 2 additional web portals.
Thanks so much, Andrew. So my name is Phil Broderick, and today I'll be doing a little bit of a walkthrough for you about the EMIT Visions portal and a few different access points, including Earth Data Search and some tutorials to really fill in the context for the rest of the EMIT data acquisitions. So you might be thinking, okay, we've already talked through one way to access the data. Why are we going to talk through a couple more? Well, like many different tools are good for different applications, and it really all depends about what your science and applications use case needs are. So the tutorial that Andrew just walked through, accessing EMIT data through the U.S. Greenhouse Gas Center, is really ideal for comparing EMIT data related to CH4 and CO2 to all of the other types of data available at the U.S. Greenhouse Gas Center. There are data available from multiple agencies that are in situ and airborne and orbital, and all of those data can be found together at the U.S. Greenhouse Gas Center with appropriate context so that you can discover and compare between those different data sets. It's really the ideal place to do that. On the other side, when we get into EMIT data, if you are an expert EMIT data user and you want to get some more context around those particular data sets, well, there's plenty of additional EMIT data that aren't necessarily greenhouse gas data. There are RGBs, and there are spatial mosaics and cloud cover metrics and geometry metrics and all sorts of things that you might want to use for different science and applications needs. So if you're looking for that additional context about EMIT, then this visions portal that I'll demo in just a minute is a great place to look for. And then finally, Earth Data Search is the broad home for all of NASA data. So if your goal is really to use and compare different EMIT data sources, Earth Data Search is really the place to go because you can pull all of those different data sets and query all of them spatially and temporally at the same time. And so we'll walk through these second two use cases here today. So in this visions tutorial that I'm going to start with here, we're going to go in just a second to the site that hosts this. And we're going to take a look through a few different examples. We're going to walk through the portal and kind of understand how to use it. But then we're going to utilize it to understand when and where EMIT data have been collected, to explore where EMIT data might be collected in the future, so we can get a little bit of that kind of temporal context. We'll understand some auxiliary data around the EMIT detections that might be useful in the context of greenhouse gas emissions estimates. We'll visualize a variety of EMIT scenes, and we'll walk through a few point source examples to put kind of all that together. So now I'm going to go ahead and transition over to this link to get to the EMIT Visions portal. All right, so now we've made it to the Visions Open Data Portal. This is back-ended by a tool that's called MMGIS, which has been developed and deployed for all sorts of different applications, including tracking the rover location on Mars. So it supports a broad range of other applications. Here, we're using it to explore EMIT data. And when we land on this page, we're going to see a variety of different options up top. So we have this coverage and forecasts option. And then we have a different view that's similar to the planet that is going to show us the greenhouse gases. Now, both of these actually just reference the same application on the back end. So you can access all of these data together in the same way. It's just showing you different visual front ends. So I'm going to switch to a full screen mode so we can see this a little bit more clearly, which you can do by coming down here and hitting this full screen button on the bottom left if you're following along at home. So I'm going to do that and switch to another panel. And here is right back where we landed on the initial screen, just in full screen mode. So this is a fully interactive data visualization browser. So here we're starting out and with a relatively global view of the Earth and EMIT data acquired to date. I can zoom in and out on any location, either using the scroll bar or using these plus and minus arrows in the top right-hand side. And by default, what I'm looking at is data with just a red, green, blue image of what EMIT was seeing on the ground with the associated coverage and FIDs. Now, this is zoomed in for a particular point in time, just like we're zoomed into a particular point in space. So if I click and drag this slider, I will expand the temporal range or contract the temporal range of data that we're querying. And I can do that either using this time slider at the bottom or by using these active time bars. So if I have a very precise date that I want to select, say November 22nd, I can do that, and I can even go down to the exact time if I would like to. So you can use those to make that a little bit more clear. This time bar, I can click and drag if I want to see more or different portions of the range. And you can also use the scroll bar on your mouse to zoom in and out so that you can see more or less of that context. So that's the basic mechanism by which to explore different places through space and time. And again, looking at our default view of EMIT RGB data. So I'm going to go over here now to the left-hand side on the top left and take a look at some of the different layers that are available. So we've had these default coverage and RGB layers on. I can turn on and off any given layer just by clicking this square over on the left-hand side. And we're going to walk through all of the layers in a little bit more detail later. But first, I just kind of want to show you some of the utility here so we can walk through, turn these on and off. We can also reorder the layers if we need to. So if we're looking at one product and it's more convenient to have something on top of or below another layer, we can reorder it like that. And we can also change some settings as needed too. So if I need to change the brightness or the opacity of any given layer against the background, we can do that here. We also have a few different backgrounds defaulted. So just like you might have in any sort of map viewer, we've got a hybrid base map here that's got some labels on. But if I just want some plain satellite overview, I can do that. Or I can flip over to an OpenStreetMap view of the world if we'd like that context. So you can use any of these as you see fit. And that kind of gives you the sense of how to toggle on and off different data layers. We'll come back to looking at the specifics of what these different layers are in just a minute after we finish the quick overview here. So just continuing to come down on the left-hand side, there's some additional tools. When I click on an individual layer, there's an info tool that's going to provide all sorts of additional metadata for me, where I can look at different context around there. We're going to come back to this specific example in just a minute, but this is how I can get info about any given layer. And then we're going to skip past the sites because I don't actually have any of those loaded right now, but there's also a measure tool if you just want to get some spatial information about how far things are away from one another. Continuing down on the left-hand side, there's a handy little feature here called copy link. So if I go to any particular spatial and temporal zoom in, if I want to be able to share that with a friend, all I need to do is hit that copy link button, and it's going to copy a URL that's got a tiny link associated with it that allows me to share this exact spatial temporal view with someone else. Similarly, you can just take screenshots if you'd like to download something. We've already talked about that full screen. And then there's a hotkey section if you want to take a look at what some keyboard shortcuts are to toggle between different modes. All right, we've already talked through the time layer, and so that pretty much finishes up our overall view through the interface. So now I'm going to walk through the different layers that we have available for EMIT data and talk through what each one of those are in a little bit more detail. So first and foremost, we have this coverage layer and the RGB layer. Those are the ones that we're looking at right now already. And these are showing us a variety of different pieces about the surface. I'm going to move this forward towards our most recent data set here now. So I can show you kind of the view that you might come to, close to the view that you might come to when you land on the page. And the first thing that you can note is that there are blue tiles and yellow tiles. So the yellow tiles are actually things that haven't quite been delivered to the land processes DAC yet. So these are en route. Usually they're somewhere in the process of being transformed to radiance and to reflectance. They're somewhere in that process, and so you should be able to see those in the very near future. But they're available here a little bit early, kind of as they come through. And you can also, if you click on any one of these layers, like we talked about earlier, get some additional metadata. So you'll be able to note, if you go into the info tool, the associated geometric values with the scene. So things like the path length between the instrument and the ground, or different solar phase angles, sensor azimuth angles, all this type of ancillary information that might be helpful to figuring out things like what the general SNR of the scene might have been. You can also view some convenient metrics on things like the total cloud fraction that's within the scene. So there's different types of clouds. This total cloud fraction is the overall total number of clouds within the scene. So you can see that this is estimated at 90%. So if we zoom in on the scene, it's probably pretty cloudy. Yep, there it is. This is estimated at 90% cloud cover. And so you might want to filter on some of those scenes for things like this, depending on what your analysis are. So you get some metrics there. And then critically, you'll also notice a whole variety of download links. So you can access those either right here, or you can actually access those when you go to click on an individual scene. There's a shortcut for them over here on the scene where you can drop down to each one of these links. Now, this is going to be true of every vector layer that we look at here. And if we go to this link and we click on this link, it's going to take us immediately to download that data set straight from the LP DAC. The only requirement on being able to do that download is having an Earth data search login account, which if you're not logged in, this will take you to the login page to log in. And if you don't have an account, you can just hit the register button and create an account right there. Once you have that, those accounts are free to create. Once you have that, you can download any of these data sets that you like. I'm going to come back over here to the layers button now, so we can do that critically for any of the associated EMIT data sets. So here we have the L1B observation data. That's the geometric data. So these are things like the solar zenith angles and some of these values that are summarized down below. We also have the core radiance data. So this is a 285 wavelength radiance data set. We also have the L2A masks. So this will tell us something about how much AOD and water vapor and clouds we anticipate were in the scene at any given pixel, so we can filter things down more. We've got the level 2A reflectance, so what we've modeled that the surface reflectance look like, and the associated surface reflectance uncertainty. So these are all kind of ancillary data sets. But this is a greenhouse gas tutorial. So I'm going to go over here to the left-hand side and turn on a couple more layers here, including the methane plumes. So everything that's down here on the bottom left, these are raster images. And these ones up here, these are our vector layers. So I'm also going to turn on our methane metadata here. So if I zoom out with this same view, we're now going to start to see a variety of methane plumes. I might have to expand our time window a little bit. We're going to start to see, a whole series of methane plumes show up in addition to these RGB layers. And I can turn, if I want to, I can turn those other layers off. So now we're only looking at methane. And if I hover over each one of these, I can see a little bit of basic information. But just like with the RGBs, I can click over here to the info tab and I can get additional information. So I can get the latitude and longitudes of the maximum concentration along with a data download link to download the raster image that I'm looking at. So I'm going to zoom in on a particular example here. And we can come all the way in, we can see what that looks like. And now if I wanted to, I could download that plume complex right here. Also, when I click on any particular vector, I get a few different summary stats up top. So for example, this is our running total of how many plume complexes we see. And you'd see similar data for the number of scenes observed by EMIT if you go to the coverage layer. But you'll get a little bit of summary statistic up there. So we've now gone through the methane data, the RGB data, and the coverage data. Similarly to the methane data, I can turn on the CO2 plumes. I'm going to open up our time window here a little bit, and we'll see a variety of different CO2 plume enhancements from different locations around the globe. And similarly, we can find the download links to those data as well. So this works the same way as the CH4. And then some additional information that is very valuable, if I zoom all the way out, one of the things that we get asked most frequently because of the complicated orbit of EMIT is where has EMIT collected data, and where is that data cloud free? And so if I zoom all the way out, this is a layer that will show us for each month. This is a monthly average, or not monthly average, a monthly aggregate of all of the cloud-free data we've seen that's mapped out spatially. So this is looking at around November 2023, and this was all the data collected in that month, but I can expand this time window to see where we were covering data, and the cloud mask has already been applied here. And that's pretty critical when I'm trying to think about methane data through time and try to figure out where were there valid observations in contrast to where we saw the actual detections at. So this is a useful layer in that context, and we can look around through that whole time range. If we zoom all the way out in time, then we'll get a sense of all of the data, all of the regions of the planet that EMIT has collected data from to date, which is, of course, expanding all the time. This layer is updated approximately monthly with a little bit of a lag, but the RGB and the coverage layers are updated every day. So we see those data as they come on through. There's a few other critical features that I want to show. There's the target mask here. This is a little bit old. This is showing what the target mask was for the EMIT Prime mission. This has been expanded upon dramatically now, so it basically includes everything between plus or minus 50 degrees that's over the major land regions. But we can also get a sense of where EMIT is going to collect data in the near future. So if you're trying to time out some field experiments, we go to this forecasted coverage layer up top, and I have to expand my time horizon to include the present. Now we'll see where EMIT is going to collect data into the future. And there are two colors here. There's a red color and a green color. The green color is within the current sequence. Everything that's in the red is forecasted, but is going to change depending on how much data we collect in the previous week. So this gets updated every week with the expected coverage, and you can click on an individual scene and get information about the exact time and the solar geometry of that anticipated collection. This should be used with caution. So this is a planned acquisition mask, but of course, any operational constraints, any maneuvers that the ISS has to make over the week, or any interruptions to service might modify what data are actually collected. There's also an onboard cloud screening algorithm that's deployed with EMIT, which will change what data are collected at any given time. So if there are too many scenes within the actual cloud, we don't download those data to maximize the utility of our downlink bandwidth. So again, these are not a guarantee that we'll have data over any given one of these regions, but where we're planning to attempt to acquire data. You can get a little bit more information if you want to look at the very long-term trajectory of where EMIT is going to go. So this is a 10-day forecast that's updated every week. If we click on this layer, we'll get the potential long-term coverage. So this is now an 8-week forecast, which is going to show us all of the regions that EMIT could potentially acquire data. The actual acquisitions from EMIT are complicated by the amount of cloud cover in any given scene, the amount of availability we have on our different storage buffers, and a whole variety of different operational constraints. So this doesn't say we're going to collect data over any given one of these regions, but it does give us some anticipated insight into where valid data might be. So we're going to try to collect these data below this 45-degree solar zenith angle. That's for signal to noise. We get much better data under these conditions whenever we can. We also show kind of these yellow zones. So what this can be used to do is highlight that over the next couple of months, really the southern hemisphere, right, is getting a lot more coverage than the northern hemisphere is. And this can give us that kind of an insight. what time regions you're seeing have the most data available, and you can use this to zoom into a particular window and get a sense of what the coverage is anticipated to look like at a particular point in time. This is a little bit of an overview. If you're trying to look forward into the future to what data might be coming, this gives us a little bit of information there. But perhaps the most interesting thing that we can do in the context of greenhouse gases is to take a look at the data that we have and look back into the past. So I'm going to go back here and turn off these layers and turn on the methane metadata and the methane plumes. I'm going to expand my temporal window to look at the entire duration of observation of the EMIT mission. So all the way back to August of 2022, when we started collecting data in orbit, all the way to present. And I'm going to take us to a particular example now, that a great example of exploring data temporally. So this is a landfill in Jordan, and you can see from this image how the data, how multiple scenes are acquired from the same location, and we're seeing a very persistent point source emitter. So this gets a little bit messy and a little bit complicated to view this whole scene. So a good thing to start to do is to filter it in time. So if we go all the way back to the beginning of the mission, we see a few different points. So this one all the way back on August 10th of 2022, and you can see that this was just a tiny little emission relative to some of these other ones. And then we can start to expand these forward in time and take a look at what these different emission sources might have been at different points, and grab, again, each one of these that we want to download. We can download any given one of these scenes. This gives us a little bit of insight into how we can explore these data in the temporal context. But as you can kind of see, as I start to move this slider around, it can be a little bit tough to figure out when I should expect the next piece of data to show up. So there's some tricks that we can use to help with that. So if I come here and I click on a particular location in time, I can go up to this feature navigation component, and I can change this. So by default, it's just going in whatever order these plumes happen to be in. But if I choose the map end time choice, and then I fix the boundaries of my search to the map extent and to the particular geometry type, then I can start stepping forward in time. And every time I hit this forward arrow, it's going to bring me to the next observation. And if you are watching this slider on the bottom, you can see that as I advance, it's actually stepping me forward to the next observation that occurred here. So this is a good way that we can be expanding our window and thinking about these observations in time. But a critical thing that you might be thinking of is to say, well, okay, now I'm seeing these emissions, but what happened in this period? So I saw a lot of acquisitions to date here, and now I'm not seeing anything that's going on over here. Well, what happened? Did the emitter, did this source stop emitting methane during this period of time? Or did something else happen? So we can go into this time point, and to try to figure out what's going on, we can bring in some of these other layers. I'm going to turn this coverage layer on and our RGB layer on. And what becomes immediately apparent is that there are no acquisitions in this period. So in fact, if I zoom out, there are no acquisitions globally during this period of time. And that's because this was during a short interval, where a 3-month interval, where there was a power disruption supply to the EMIT instrument on board the ISS, and we weren't able to collect any data during that period. Fortunately, some repairs were made to the module, and EMIT was able to begin collecting data again. And if I step forward, I can see when those additional data started coming through. So that's the type of thing that I can figure out. Okay, there were no acquisitions during this time. That explains why I wasn't seeing any methane metadata. showing up, but I can also get some insight into things where maybe there were data collected, but they weren't relevant. So if I look at an interval, say this time period, if I zoom in, there were acquisitions that occurred prior to the methane showing up, but these were very cloudy acquisitions. So you can see big stripes where there are no data coming through. That's when the onboard cloud screener was on. And then you can see many points in time where there were a lot of clouds. There might be high thin cirrus involved in here as well. And in general, we weren't able to make a detection. So this is pointing us to the fact that the main reason that we're not seeing observations during this period of time is that the conditions were not optimal in order for us to be able to see those. As we advance further in time, now these start showing back up. And if we zoom in on that point in time and keep these scenes up, we'll see that these scenes, while there are some clouds in them, in general look like a lot better conditions. And I'm going to turn the coverage layer off here so that we can see these overlaid on the RGB. And we would have to get very specific in time in order to isolate any given one of these plumes. But we can do that. So we can go all the way down so that all we're seeing right now is the relevant RGB in the background. And we can see the relevant plume image right here overlaid. Just for fun, I'm going to go ahead and take this image and I'm going to make it partially transparent so that we can see what's going on behind it and figure out kind of that spatial context. And say we really wanted to investigate this scene and figure out more what was going on, I could turn on this coverage layer now, select this layer, and I could go download the actual radiance data that were used to make these methane detections along with the associated observation geometry file or the associated reflectance files. So this gives us a bit of an overview of ways that we can use this portal and this time slider to look at data over different examples and different point sources, to explore it through time, and to put it in the context of the general other EMIT acquisitions. So with this, I'm going to step back to some slides, and we'll talk through some other ways that we can explore EMIT data. All right, so next up, we're going to take a look at some additional ways that we can explore EMIT data using the NASA Earth Data Search tool. So we're going to take a moment to look and find how we can download EMIT as well as other data sets from this tool called Earth Data Search, and how to find some additional documentation on other EMIT data products if you're curious and you want to learn more about those. Then we're also going to take a quick look at some other tutorials and open source code so that you have some resources available if you want to dig deeper and learn a little bit more about the EMIT instrument. With that, I'm going to step over to Earth Data Search. Okay, so when we go to search.earthdata.nasa.gov/search, this brings us to Earth Data Search, which is our general home for finding all of EMIT data, along with all other NASA-hosted data products. So when I come here, I immediately get the option to search for different collections, and I'm going to start by searching for EMIT. You might want to put that in full quotes because EMIT is a general term that is going to come up with other pieces of information. But if you put it in quotes, we're going to constrain it to data from the EMIT instrument. And here you can see all of the different collections of data that EMIT produces. For each one of these, if I click on it, I can see a whole host of different acquisitions, each individual scene. And then I can also find ways to download the data. So I can click here to download individual scenes, just like we could from Visions. But here we can also find links to AWS S3 access. So if I go over here, if I'm interested in working with these data directly on the cloud, especially if you're in US West 2 on your AWS instance, you can download or you can access those data directly with no cost. And there's documentation available through these different links about getting the relevant S3 credentials and how to pull those data directly into an instance, along with specific information about the relevant buckets on how to download those or how to access those data. If I come back up here and I go back to my search results, I can see all of the different information about EMIT and all the different data sets available from EMIT. And if I click on these additional information, you'll also get to references to the dataset landing page, user guides, and additional information along with the DOI and all the kind of information that you might want to use if you're trying to dig deeper into this particular data set and figure out how to utilize it for your research or applications project. So I come back here. One of the things that this tool allows us to do, if I come back to the same example here in Jordan, I'm going to remove these EMIT keywords now, bring us back to the main page. But one of the things that I might want to do here is to use a bounding box. Just put a box over a fairly big region here. I did that wrong. Let's try again. Put a bounding box. There we go. Click and drag over the particular region of interest. And now I'm going to go ahead and put a time filter on here too. So let's go ahead and start roughly when EMIT started collecting data. It was in August of 2022. And we'll go ahead and bring that forward to today. And we'll go ahead and apply that filter. When we put these two spatial temporal filters in, now we can start to see all of the different data sets that are available from NASA over this location. So I'm going to click on one of these. Maybe I'm interested in Sentinel level 1A or Sentinel 1A data. And here I can figure out what those individual granules are, and I could download those individually. Maybe I'm interested in some topography data, so figuring out what the surface elevation is over a given region from SRTM. Here I can go to those data sets and I could pull and download those data as well. And I can do things like go and collect temperature data of the surface from EcoStress that's coincident with these. This one, because it's on the International Space Station, if I'm grabbing data from here, it's probably very coincident with my EMIT data. So you can use these data together for different research projects. So this just highlights all of the different data sets that might be available within the same spatial and temporal window as a particular piece of information that you're looking for. So this is a great resource if you're really trying to expand and dive deeper into maybe what were the possible reasons for the methane emission that you're seeing, or what other aspects of the area are relevant in the context of answering different research questions. Each one of these data sets, of course, requires some amount of knowledge to be able to utilize directly. And a great tool that you can reference in order to do that in the context of the EMIT data is the NASA EMIT data resources page. So here, this is a new page that we can go to, and we can find a whole variety of different tutorials that the LPDAC has put together for the community, and you can contribute to this website. This is in support of open science. This is all available and can be PR'd into. And this has resources about how to use Earth data search if you want a visual walkthrough of what I just talked you through at a very high level. Detailed information about how to stream data from EMIT straight into QGIS, or how to explore the EMIT reflectance data, how to extract subset and transform data into different forms and different data sets. And then how to use NASA's CMR API. So I just want to highlight that everything that we just did in Earth Data Search, you can do via an API. So if you prefer to make some calls via Python or the command line, you can do that directly if you're trying to automate that process into your workflow. And so there's a tutorial here specifically on how to do that and access that with EMIT data. And many other missions have similar contexts, have similar sites to this where you can get some additional context. There's also a whole series of additional webinars and ways that you can expand thinking upon this and build off of the training that you've heard about today in part 1 and part 2. So in summary, we've now looked at how to access data a few different ways through the Visions portal, through Earth Data Search, and now even a quick deep dive into where, or a quick resource link into where I can go to if I would like to do a deeper dive and to explore these products at a different scale. And I hope this gets you excited about trying to use EMIT data for your research applications. With that, I'm going to pass it back to Melanie to wrap us up.
Thanks, Phil and Andrew, for those great data portal walkthroughs. Before we conclude, I'm going to give a brief summary of our training. In part 1, we learned how methane is a potent greenhouse gas that has shown large increases in recent years. It is an attractive target for mitigation activities because of its short lifetime and its responsiveness to emission reductions. Satellite observations are a key part of showing the effectiveness of policy changes for methane emissions. We learned that the goals of the U.S. Greenhouse Gas Center, led by NASA, EPA, NIST, and NOAA, involve making data that supports decision-making, improving the quality and reliability of information, and providing users with consensus information to enable climate change mitigation. While methane has both natural and anthropogenic sources, this training focused on satellite observations of methane point source emissions. Point source emissions are emissions of methane from a distinct location on the ground and can come from different emission sectors, such as oil and gas, landfills, and agricultural activities. The EMIT sensor on board the International Space Station is an example of a satellite point source imager. EMIT methane observations can be used to locate methane sources associated with known pieces of infrastructure, discover unexpected emissions, maybe not in inventories, and track methane point source emissions over time. In part 2 today, we heard about several ways to access EMIT data. Phil provided some great guidance on why you might choose one portal over another. For example, the U.S. Greenhouse Gas Center portal is what you would maybe use if you'd like to also see data from different agencies and learn about how different data sources are being used. You would use the EMIT Visions portal if you wanted to know more information about a particular EMIT observation or be able to step through plume observations in time. And since NASA Earth Data Search is the home for all NASA data, this is what you would use if you wanted to couple EMIT data with other NASA datasets. Andrew took us on a tour of the U.S. Greenhouse Gas Center portal. We saw examples of available relevant data stories and where you can find tools to access and explore the available data. He showed us how to use the interactive map from the EMIT Methane Plume Viewer to zoom in on plumes of interest and toggle the plume on and off to see sources on the base map underneath the plumes. We saw several examples of plumes from sources such as oil and gas, landfills, coal ventilation, and a waste lagoon. You can also view ancillary information such as what the maximum plume concentration is and its latitude and longitude, and a link to where you can download a GeoTIFF image. Next, Phil walked us through the EMIT Visions portal. This portal shows a user a lot of additional information about each EMIT observation. You can see where EMIT has made observations in both the past and where it will make observations in the future. using the coverage and forecasted coverage layers. Using the methane plumes and methane metadata layers, you can visualize methane plumes and find additional information on things like maximum plume concentration and its latitude and longitude, and links to download the data. Phil also showed how for sources that show multiple methane plumes over time, how you can step forward in time to see each individual methane plume observations. And we also saw how to explore why EMIT observations maybe don't show a plume where you might have expected one. In the cases we saw today, it was because of a lack of coverage, because of an EMIT outage, and in another case, because the cloud cover was too thick. Next, Phil showed us how to find EMIT data through NASA Earth Data Search. Using Earth Data Search, you can find and download EMIT data and documentation. You can also find out how to access EMIT data on the cloud, as well as using search functions like a bounding box and a time window to find other data at the same location and time to complement EMIT. The EMIT Data Resources page that Phil showed is a repository that contains tutorials and open source code to help you access and work with EMIT data. A quick reminder, this training series will have one homework assignment. You can access the homework from the training webpage starting today, and answers should be submitted via Google Forms by December 5th. Certificates of completion will be issued to participants who attend both live trainings and submit the homework before that deadline. Certificates will be issued by email about 2 months after the training. And here is the contact information for myself, as well as the speakers for our training, as well as links to the ARSET website, YouTube channel, and Twitter or X, and our sister programs, Develop and Surveyor. And here again is a list of resources mentioned during today's training. And I wanted to give another thank you to our fantastic speakers, Drs. Leslie Ott, Andrew Thorpe, and Phil Broderick, and a thank you to Dana Chadwick for her contributions to this training content. And thank you all so much for joining us today. We'll now transition over to the Q&A part of today's training. Okay, so here we'll start with our question 1. Is there an equivalent to the U.S. Greenhouse Gas Center at a worldwide scale or for other countries other than the U.S.? And it looks like Leslie, who's joining us again, will tackle this first question.
Yeah, thanks for this, and thanks for the great question, and also the great training from Andrew and Phil today. So the answer is not quite, or at least not yet. There's nothing as quite as far-reaching or as comprehensive as the Greenhouse Gas Center is growing to be in terms of a data portal. But there are some great resources that are spinning up that tackle part of this problem in providing consistent data across many different data sets that are collected internationally. So there's a couple examples here. First is one that is maintained by the UN Environment Program called MARS. This is developing a data portal. It's still fairly new and in development, but this is developing a capability to bring together other types of point source data that are provided by different satellites that are maintained in some cases by private industry or international entities, so that people can get alerts from these kinds of data. And that's important because really the Greenhouse Gas Center is providing the science basis for decision making, but we are not an enforcement agency. We are not a policy agency. So there's an important role for other agencies like UNEP in translating some of those data into a direct warning that some stakeholders need. For other types of data set that you haven't seen in the trainings, but you would find on the Greenhouse Gas Center, things that tell us about global net emissions of things like carbon dioxide and methane. There are also international initiatives, including ones spinning up from the World Meteorological Organization, which will help coordinate some of those data products and provide them in a more central location, but that's still several years away. So right now, you see some of these things spinning up, but there's not quite an international analog to the Greenhouse Gas Center yet. And I will say that other countries are interested in this model. In the US, we have this great but challenging environment where you have all of this information provided by different agencies. And in other countries, the structures may not be exactly the same, but they may have the same challenge of trying to provide consistent information across a large array of government organizations. So, for example, we talk a lot to colleagues in Japan who are working on a similar type of approach to consolidate data and be able to speak with one voice and contribute from those data portals to international activities like the UNEP one, like WMO. So it's an active area of development. Stay tuned because this answer is going to change over time. But right now, keep an eye on some of these things and please keep checking back because the website is growing all the time.
Thank you so much. Okay, question 2. Why are there more super emitter plumes from the Permian Basin? We saw a number of examples from there, compared to other basins in the US or North American, Canada included, landmass. Is it because it's just a higher density of wells and thus compressor stations and production equipment?
Great. So that's a great question. And the Permian Basin is the largest producer of hydrocarbons in North America. And I think that that's one of the primary drivers for why we see both very large point source emission events, and many of them, as we've shown in the last, I guess, 2 tutorials here. We also know that in the Permian Basin, we have a very high density of wells, given there's so much hydrocarbon that's being extracted. And we also have a lot of very large facilities that are kind of concentrating all of that hydrocarbon to centralized locations that can lead to more emissions. So I talked a little bit about the compressor stations. If you were to just use Google Earth and go to the Permian Basin, I'd encourage folks to just sort of zoom around and look for these very large facilities that are, there are quite a number of these, right? And we know that these have been large emission sources historically, and we're seeing that in the EMIT results. So, but that's a great question.
Great. Okay, question 3. Do large livestock feedlots, not wastewater lagoons from them, generate a detectable methane plume?
Yep, and then this is I'll take this one as well. Another very good question. So we featured a few examples from wastewater treatment lagoons, and the reason that these are relatively more prevalent in our data sets is because it's a sort of a concentrated source of methane coming from the waste that's in that wastewater lagoon, be it in the agricultural dairy sense, or in that example that I shared on a beet plant, a sugar facility that had a waste lagoon that was emitting methane. So to date, with EMIT and AVARIS, the airborne instruments like AVARIS Next Generation, AVARIS 3, we've really been limited to seeing methane emissions from these waste lagoons, and we have not been able to see sort of a more diffuse, weaker emission that would be coming from the feedlot in aggregate. That's much harder to do, but the question points out, I think, a good point that we would expect, and we know that there are going to be weaker emissions from these facilities because there's cows and cattle there and things like that. It's just that current technologies struggle to see those types of emissions.
Okay, question 4, how thoroughly does this data set capture super emitting methane events? Does it include a specific concentration threshold, either, I'm guessing, for detection or by classifying it as a super emitter event?
Hey, this is Phil, I can take this. This is a great question and one that we get asked a lot. So one of the keys here is that there's a lot of effects that end up influencing what the what you can detect and what you can't detect. And to the first order, the most dominant of these are the surface albedo. So how bright the surface is that you're looking at. So for at the extremes, if you're looking over water that doesn't have any glint on it, you're not going to see any methane, or you're very unlikely to see any methane because the water is going to absorb all the photons that hit it. On the other side of things, if you're looking at a bright desert surface playa, you're much more likely to see things. And so that's one of the primary controls. The other one, which doesn't control the concentration threshold, but does affect which plumes you're going to see and which ones you aren't going to see, is the wind speed at the surface. So the faster the wind is blowing, the more quickly you disperse the methane, and the less likely it is to build up to a concentration level that is detectable by your satellite. Some recent work is looking at quantifying some of the uncertainties from the former of these processes, and we're going to look to try to incorporate some of the results from that into the products that we produce in the future.
Thank you. Question 5. In the first part of the presentation of the EMIT platform, part 1, the plumes were shown, but these look hand-drawn. Is this true, or is there an algorithm outlining the plumes?
This is Phil. I'll take this one again. Absolutely spot on. So good eye. These are in fact hand drawn, and right now the process for identifying any individual plume from the background involves a 3-person review process. So there's someone who primarily identifies those plumes and does hand draw a label, and then those labels are touched up, refined, and approved by 2 other reviewers before they're published. That process is documented in the PDF link that's available there in the EMIT greenhouse gas ATPD. We are working very hard at automating this method through various machine learning methods and other mechanisms, but it's a challenging problem to do generally and robustly everywhere on the planet. So almost all deployed operational versions of plume identification to date still use hand-drawn plumes. I will say that the EMIT data provide an excellent data set as kind of a reference, either training or evaluation data set for any of those more automated methods. Certainly that's how we are using them right now, and I know that others are as well. And we look forward to seeing new algorithmic developments that allow for this to become a fully automated process.
Great, thank you. Question 6. I'm interested in using EMIT data to see if natural methane emissions from wetlands are detectable. Are there resources for generating new methane plumes from the raw data?
Yeah, absolutely. So this is a great question, and I did want to, I guess, start with my response, and just to emphasize that I'd encourage folks, if you're interested in these types of emissions, to check out the paper that I've included here from a colleague, Clayton Elder, that has published on airborne results from permafrost emissions of methane, which is really exciting capability to date. So if you want to take a look at that, please check that out. So currently, while we do have coverage with EMIT over wetlands, we have not yet identified any really high confidence examples of what could be emissions from wetlands. That being said, I think what's nice about making all the data publicly available is that that empowers anyone to go ahead and take a look at those results. So I'd go ahead and get some data, maybe or through Earth Data Search to over wetlands of interest, and you can take a look at what our results are looking like, and you can start to think about, you know, these results and how you might want to try to use them if you see anything interesting going forward. In terms of the, you know, I think as we stated a little bit earlier, all of our code for all of the data processing and visualization is publicly available, and we have that GitHub link. So please check that out. I think that should help you get on your way to looking at this data in more detail.
Great. And as we go, we're putting the links you see here in the chat wherever we can. But this Q&A doc will be posted to the training page, so you'll have access to them later as well. Question 7. Are methane plumes affected by precipitation? Do rainfall events diminish, enhance, or mask them?
Yeah, this is a great question as well. I think I want to reframe this a little bit in a slightly different way. I think, but it's I think getting to your original question here. So, if as Phil was showing in particularly in his part of the presentations, right, cloud cover and rain events, right, basically obscure our ability to look at the surface of the Earth where these point sources are coming from, right? So unfortunately, when you've got cloud cover and precipitation, we really aren't in a meaningful way able to look for methane plumes for that given observation. That being said, right, the EMIT instrument does return to these locations, and we often do wait for cloud-free acquisitions, and then we'll be looking for plumes, and if we see them or not. There surface water, you know, if there is a rainfall event and there's a lot of water on the ground, it will darken the surface, particularly in the shortwave infrared, making retrievals more challenging. And if you've got a lot of rain, a flooded field, something like that, again, we have almost no signal in the shortwave infrared there. The only approach to try to mitigate that, to look for point sources over water, is to actually use sun glint, right, where we're trying to optimize to make the sun act as a, you know, reflecting off of the surface of water and then into our instrument. And we have shown results using airborne instruments where we can actually do that in a sort of operational way. It's more challenging to do from EMIT because we can't point the EMIT instrument off of nadir, so it's looking directly down, and we're sort of at the whims of the space station there.
Okay, question 8. Is it possible to download the methane plume data as a CSV file for future use? And can I download CO2 or carbon dioxide data?
Hey, I'm happy to take this one. Yes. Well, sorry. It's not directly possible to download the data as a CSV file, but it is possible to export the data as a JSON, KML, or .shp file. If you go over to the left-hand side and click on that data layer, there will be a drop-down box with a download arrow, and you can select the format that you'd like to export it as. You can do this you can do this for any vector layer that's available there. And the CO2 data, similarly to the methane data, also has one-click downloads referencing to their host location on the LPDAC.
Okay, question 9. How do we get data from methane plumes and carbon dioxide? Is it possible to generate a time series profile and do analysis?
Yeah, I can take this one as well. Yeah, so the in order to download, so you can download the individual methane plumes, kind of as we've linked to and referenced throughout. There's also, I will call out for this, there's another tutorial that we referenced from the ones that are hosted on the EMIT resources page, where this exact exercise is done in a Jupyter notebook, if you would like to explore that in more detail. So from there, you can kind of look at the exact time series and profile. You can also export the vector layers from what you see on the screen. So if you do the download like we just talked about for the vector layer for the JSON files, When you do that download, if you've subset your spatial domain to only what you're seeing on the screen, that's what you're going to get downloaded. And so then you can look through those JSON files and map them out through time.
Thanks, and we'll make sure to add that link so it's available when the Q&A is posted. Question 10. Are you planning to collect data for Nigeria in the near future? And this would, I guess this question would hold for any country you might have in mind.
Yeah, so in general, kind of as we talked about in part 1, EMIT is constrained in its ISS orbit to only observe, because it's a nadir viewing instrument, only view locations that are roughly plus or minus 52 degrees in latitude. But anywhere within there is fair game. And over the course of the next year, any location that's in a terrestrial system that hasn't been observed to date is likely to get at least one observation. If you keep checking back on that forecast portal, you'll see where it's going to collect data in the next week.
Okay, question 11. It looks like the example plume in Jordan is spreading outside of the observed area. Is this a common phenomenon that a plume is detected, but EMIT does not actually capture its full area and volume?
I would say, yeah, it happens a decent amount. So the EMIT swath is something like 80-ish kilometers wide. It depends where you are on the planet and what altitude the ISS is exactly. But it's a finite swath, as is any push broom sensor like this. So there's always going to be a boundary that comes into play. And many of these plumes end up being very large. Some of our examples that stretch across whole scenes can go for 100 kilometers or more. So in those cases, it's not unlikely that the plume falls off the edge of what we happen to be detecting. Or sometimes starts outside of the edge, and then only parts of the plume drift into the interior. So certainly this happens all the time. Fortunately for quantification efforts, data that is closest to the point source itself is the most important for that quantification effort. So locations where we can see the origin of that plume source, you should be able to do at least a proximal quantification effort.
Okay, question 12. Is there any way to detect smog with EMIT data?
This is a fun question. I had to think a little bit about what might be possible here. So we regularly, the instrument is very sensitive to water vapor in the atmosphere. It's also quite sensitive to aerosols and different aerosol types in the atmosphere. And we've done a variety of research in the past, mapping out different aerosol types and distinguishing them. And we provide as an operational product, as part of the derivation of the surface reflectance, the amount of water vapor and the total amount of aerosol in what's called the aerosol optical depth, or the thickness of the column, as products that are in the EMIT L2A mask product. Now, smog is going to be complicated because of the interaction between the two. And I personally have not done, nor have I seen in the literature, an explicit retrieval for smog. That's not to say that there isn't one out there. Many people have done very creative detection strategies. And this would certainly be a great topic to look for down the line as a fun research topic.
Great. Okay, question 13. Looks like a two-parter. First part, is it possible to download a subset of EMIT data? And then a follow-on, maybe we'll tackle that first.
Sure. So a great place to go do this is the NASA Appears site. I've put a link to that tool here. So data that are available through many of the DACs are available here. And in this case, EMIT L1B and L2A are available there. You can upload a shapefile, with a polygon or a series of point data, and there's a walkthrough on how to extract a spatial and temporal subset of data from EMIT. You can also find a tutorial for how to use Appears, I believe, on the EMIT resources page.
And a couple questions ago, we had a question about, plumes that extend off the edge of the swath. This is a kind of a similar question. Have you noticed a lower quality of the reflectance or radiance data in the pixels located at the edges of the products or towards the edges of the sensor swath?
Yeah, so this is a very astute question. There are a variety of things that happen in the cross-track dimension of the sensor. So when this type of imaging spectrometer is a push broom, so it has a focal plane array, and it's really not one spectrometer. It's really many thousands of spectrometers all working together, many thousands of detectors. And so every one of those is calibrated independently and then collectively together. So there's a variety of effects that happen. One is just simple geometry effects. So you're seeing a different path through the atmosphere with slightly different zenith angles and different overall path lengths as you look towards the edge, as opposed to when you look towards the center of the column. And those we largely take into account in the process of the reflectance calculation. They affect the radiance data, of course, but they're captured within the observation geometry. Then there's a few effects that can come into play towards the edges. So we have different calibration effects that can vary in their efficacy in the crosstrack. And typically the quality remains high right up until the last pixel or two. So in the very extremes, you can have some degradation of performance. And that's something that we're actively working on all the time to try to get better. So you'll see it change and evolve over time, but there can be some very slight edge effects, but only for the last pixel or two.
Great. Okay, question 14, and we have time for probably about one or two more questions. What are some ways that generally technical individuals can use EMIT data to engage in the mitigation effort, either locally or globally?
Yeah, I'm very happy that we just have enough time to take on this question, because I think it's a really important one. So, I think EMIT results do have the potential for that direct mitigation, and over the last few years, both with our airborne instruments like AVIRS Next Generation, AVIRS 3, and more recently with EMIT, we do know that if we share these results and make them publicly available and easily accessible by folks like yourselves and organizations that want to do something about these emissions, that it can actually lead to direct mitigation. So we have examples of that. It's one of the reasons we're so driven to continue to make these available publicly. And not only for examples where you can just do a direct mitigation, let's say, of a landfill that's emitting methane, like some of the examples that Phil was showing, right? But more broadly, I think once you start to understand where methane emissions are coming out of the ground across different sectors, that can start to percolate its way into these discussions about like broader mitigation strategies, right? So if there's organizations that are trying to do emission mitigation across oil and gas or ag or landfills, right, then these types of results can really, I think, empower folks to think about like what are some strategies that could be effective, right, for these low-hanging fruit examples of methane point sources, right? So it's a great question.
Thanks. And these great questions are also giving us at ARSET ideas for follow-on trainings to hopefully work with the EMIT team again. So we have about 2 minutes left. I wanted to open it up to our speakers. Any final words or thoughts, just to give you all a chance, for a final word, if you'd like.
I'll just kick it off and just say that over the last 2 days of these trainings, it's been very exciting and humbling to see the attendees list and the participation globally from folks. So very excited to see the interest in these results. And we want to continue to do the work that we're doing and making these results publicly available and getting feedback from folks like yourselves and things going forward. So thanks everyone for participating.
I'll just echo that. It's wonderful to see such a broad and diverse community coming together here to learn more about these greenhouse gas products and portals and ways to access the data. So please keep at it with whatever your research and application domains might be, and keep using the data.
Yeah, and I'll just round out by saying thank you again, and thank you to Andrew and Phil and the great EMIT team. This is an incredibly important and challenging field of work, and we're so proud to see the results highlighted in this way. We're so proud to see the data shared openly. So this is just a great accomplishment for the team, and also thank you again to ARSET for hosting and to all of you for being here. It's been a pleasure.
Thank you all so much, and for a fantastic training, and thank you again to all who joined us for this training. Hope to see you at a future ARSET training soon. Thanks, everyone.